we come to protocol attack. Okay, so there are three different types. So this is the second one. Protocol attacks, also known as a state exhaustion attacks, cause a service disruption by over-consuming server resources and or the resources of network equipments like firewalls and load balancers. So here we try to exploit the various vulnerabilities in a particular protocol. Okay, and we try to disrupt the target machine. Okay, so you can see a particular diagram here where a bot is controlled by an attacker and some spoofed SNN packets are sent to the target. Okay, so this, since it is spoofed, it is not indicating the actual IP address of this machine but some other machine. So what happens is the attacker sends this particular sync packets. So when a sync packet is sent, a sync acknowledged packet is going to be returned back. But in this case, since it is a spoofed one, the reply will be sent to a different machine based on the IP address mentioned here. Okay, so there is a diversion. All right, so there is a reflection. So what happens is the attacker does not know that all these packets, these red lines, all these packets are coming from a single bot to send these sync acknowledgement packets to different users. So protocol attacks utilize weaknesses in the layer 3, that is the network layer, and layer 4, that is the transport layer of the protocol stack, to render the target inaccessible. Okay, so finally what happens is the target is exhausted because all these sync acknowledgement packets has to be sent to multiple users. Okay, and at one point of time it is no longer able to send any more sync acknowledgement packets, isn't it? And the target thinks that all these requests are coming from different users, so there is no point of attack, okay, observed by the target end. So target end thinks that its server is in high demand from multiple users, isn't it? So the server will never understand that actually it is an attack. So in these cases it becomes very difficult for the target machine to decide what to do and what not to do. Okay, so so this is the particular problem in protocol attack. So one of the examples we have in protocol attack is the sync flood attack. So here we already seen the previous slide, an example of a sync flood attack. So it tries to exploit the communication setup of TCP handshaking. So we already know there are 3 packets that has to be sent between the sender and the receiver in order to confirm a particular communication, isn't it? So it is the initial phase of a TCP communication. So the attackers try to exploit this. Okay, so we already know how it is done with this particular diagram. So let's see what's written here. Sync flood attack. So a sync flood is analogous to a worker in a supply room receiving requests from the front of the store. So this is a very practical example shown in order to explain what is a sync flood attack. The worker receives a request, goes and gets the package and waits for confirmation before bringing the package out front. The worker then gets many more packet requests without confirmation until they can't carry any more packets, become overwhelmed, and request starts going unanswered. This attack exploits the TCP handshake, the sequence of communication by which 2 computers initiate a network connection by sending a target a large number of TCP, that is initial connection request sync packets, with spoofed source IP addresses, so with wrong IP addresses. The target machines respond to each connection request and then waits for the final step in the handshake, which never occurs, exhausting the target's resources in the process. So there is an example given here where a worker is going to receive a request, and when a particular worker receives a request, it is going to compile all the information, right? So it goes and gets the package and waits for the confirmation. So what happens is, since it is a 3-phase communication, it is going to wait for the confirmation of the sender, right? So the server is going to wait for the confirmation. Now if the reply is not sent back, so if here you can see the sync packet is given and the sync acknowledgement packet is written back, so there needs to be a 3rd packet from the machine back to the target. So if it does not happen, then the target is going to wait for the 3rd packet to come back, which never really happens, and the target keeps on waiting, right? So it is a worker which is ready to give service to a particular requester or a customer, but the problem is the customer never appears. Okay, it never comes back. Because why? It is going to wait for the third message, which is not going to be sent back, and then the target keeps on waiting. So if it has to wait for enormous amount of requests, then you can think that the target machine will get exhausted, right? It is exploiting it is spending many resources for various connections, right? But none of the connections get completed, and then finally the target machine is going to get exhausted. Okay, I hope you have got an understanding of how sync flood attack happens, right? So just remember, in short, just remember there are three messages to be exchanged per TCP connection. So this is one message, this is the second message, but the third message never happens. That is the reply from the IP address to back to the target, mainly because that particular IP address, this question mark, this particular IP address never really initiated the connection. The connection was initiated by bot, but the bot is never going to give back the third message, isn't it? So the target is going to keep on waiting for infinite amount of time. And as it is going to happen for various such connections, the target will finally become exhausted.